before the first shadow stretched across a carved stone dial, before water dripped in measured patience through clay vessels, before the pendulum swung and the tick of gears marked the passing of moments. Time had already been moving, whispered in the slow erosion of mountains, in the steady carving of valleys by restless rivers, in the endless turning of the earth beneath the silent stars. It pulsed in the fusion of suns, in the death of ancient stars, collapsing into darkness, in the orbits of planets circling their fires for billions of years long, before a human hand drew a line to divide night from day. The cosmos has always carried its own rhythm, a music written in gravity and light. Yet without witnesses, without clocks, without language, what did it mean for time to flow? Did it exist as an invisible current, or only as change waiting to be measured? The first clocks did not create time. They only captured shadows of its passage. But the deeper the measurement became, the more elusive time itself appeared. For the closer science approached its nature, the more it slipped through our grasp, revealing itself not as a thing to be held, but as a mystery woven into the very structure of reality. Time is both intimate and unreachable, the silent current that carries every heartbeat, every star, and every thought. And still the question lingers. If no clock was there to count it, did time ever truly exist at all? Long before pendulums marked seconds with their steady sway, long before atomic clocks divided existence into billionths of a heartbeat, there was only the raw intuition of time. Humanity's earliest ancestors lived beneath skies unbroken by cities or machines. Every night, the constellations wheeled overhead. Each season carried its own winds and scents, and each dawn brought the rhythm of survival. The rising and setting of the sun became the first unspoken calendar. The waxing and waning of the moon, a silent reminder that change had a pattern. In the slow procession of the heavens, people saw order, and in that order, the first sense of time. The body itself reinforced this rhythm, a pulse that surged with fear, a breath that quickened with exertion, a heartbeat that slowed in sleep. Before mathematics, before written records, the human body carried its own inner metronome, a reminder that life itself was bound to something unseen, yet constant. Archaeology suggests that even in the Paleolithic, world humans marked time through cycles they could not name. Engravings on bones, dating back tens of thousands of years, appear to follow the phases of the moon. Notches cut in ivory may have been tallies of days, primitive records of a calendar, written not with words but with scratches of stone tools. They reveal that long before civilization, humans tried to grasp the passing of the unseen, not as numbers, but as memory, made physical. As societies emerged, the intuition of time grew into myth. In Mesopotamia, time was a divine current. The god Utu, the sun itself, rode daily across the sky, marking the eternal balance between night and day. In Egypt, Ra's journey from dawn to dusk was more than light. It was the very rhythm of existence, a cycle that echoed in the Nile's floods and retreats. In Greece, the figure of Kronos was not merely a god, but the embodiment of time's relentless devouring. Of all things, these myths were not errors of imagination, but reflections of a truth still felt today, that time is larger than life, larger than measurement. An ocean in which existence is carried, yet without instruments. Time was never counted. It was lived. The hunter knew that shadows lengthened before the return of night. The farmer felt the pulse of seasons in the soil beneath his hands. The sailor read time in the stars that guided him across water. The shepherd heard it in the change of birdsong, the flowering and withering of meadows. For them, time was not an abstract flow. It was woven into memory, into stories, into the very continuity of life itself. Anthropologists speak of time in early societies as cyclical rather than linear. Events did not fall upon a timeline stretching into infinity. They repeated. The sun would rise again. The seasons would return. Even death was not an ending, but a passage into another cycle, a rhythm as ancient as breath itself. In this worldview, Time was not a river flowing forward, but a circle without beginning or end. Every dawn mirrored the last. Every harvest echoed the generations before, yet, beneath this cyclical perception, there lingered a paradox. For though time was felt in every rhythm of nature, it could not be separated from the events themselves. There was no sense of a silent current, independent of change. No abstract dimension, stretching beyond what was lived. Time was the sunrise. Time was the heartbeat. Time was the memory of stories passed in firelight. Without events, time did not exist. This intuition is echoed in philosophy even today. What is time without change? Can there be a moment in which nothing happens, or would such a moment vanish into meaninglessness? The ancients, though they had no formal physics, were already brushing against the same questions that confound scientists now. Is time real in itself? Or is it only the pattern of change observed by minds that remember in this sense? The first clocks were not tools of stone or bronze. They were the eyes of a child watching the sky darken the footsteps of a tribe pacing through migration. The pulse of blood in the veins of the living clocks would one day attempt to separate time from motion. But in these earliest eras, time could only be sensed through rhythm itself across continents. Cultures gave names and forms to this rhythm. In India, ancient texts spoke of cosmic cycles stretching across unimaginable ages, yugas that expanded beyond human comprehension, each age dissolving into the next as the universe itself breathed in and out. In the Mayan world, elaborate calendars tracked cycles of creation and renewal. Time was not merely a backdrop, it was the structure of existence itself, the cosmic fabric upon which gods and mortals alike were suspended. But if time was everywhere, it was also elusive. The ancients felt it as repetition, but not as flow. They knew dawn followed night, but not that. Both unfolded along an invisible axis. They knew crops sprouted and withered, but not that entropy advanced in one direction only. Their time was intimate, embedded in story and ritual, yet it left unspoken the deeper truth that even as cycles returned, something irreversible pressed forward. Thus, the paradox sharpened. Without clocks, time was never isolated as an entity. It was embedded in change itself. And yet the universality of change made people suspect there was something beneath it, something unseen but constant, a hidden current shaping all beginnings and all endings. The story of time begins here, in the intuition of cycles, in the myths of gods that carried the sun, in the etchings of lunar phases on ancient bones. All of it a reflection of humanity's first attempt to make sense of what could never be touched. Time before clocks was not measured, it was breathed, it was remembered, it was worshipped as both the gift of existence and the shadow of mortality. Only later, with the invention of instruments, would humanity dare to detach time from the rhythms of the world, to carve it into hours, minutes, and seconds, to imprison it in gears and pendulums, and eventually to divide it into atomic vibrations. But in this beginning, in this ancient intuition, time was still free, as mysterious and infinite as the night sky itself. The earliest humans lived in a world of rhythms, but not of numbers. Daylight carried them into action. Night pressed them into shelter and firelight. The seasons directed migration, sowing, and harvest. For tens of thousands of years, time was felt, remembered, and told in stories. It was not yet something to be measured, but in the river valleys where civilizations rose, the first shift occurred. In Mesopotamia, under the skies of Sumer, priests and scholars turned their eyes toward the heavens. With new precision, the movement of shadows became their first ruler. Carved stones and wooden rods marked the passage of the sun across the sky. These were the earliest sundials, instruments that did not create time but captured its imprint in light and shadow. By the 3rd millennium BCE, Egyptians too were dividing the day with sundials, cutting daylight into segments that would later evolve into the hours we know in this way. The rhythm of the sun's journey was given structure, boundaries, and names. Yet the sun set, and shadows vanished. Time could not be left unmeasured through the night, so water became the next medium of control. The clepsydra, the water clock, appeared around 1500 BCE in Egypt. A vessel with a small hole at the bottom allowed water to drip in steady rhythm. As the level changed, markings inside the vessel recorded the passage of moments. In Babylonia, similar devices were used to track watches of the night. To the priests who observed stars and charted rituals, the water clock was a bridge across darkness. It transformed the intangible into something almost countable. Later, in Greece, the clepsydra gained sophistication used in law courts to limit speeches, in rituals to measure offerings, in studies of astronomy to coordinate celestial observations. Time had shifted from the realm of myth into the realm of administration. It was no longer only a divine rhythm, it was a resource to be divided and enforced. Sand, too, became a medium for this new order. The hourglass, emerging in late antiquity and gaining prominence in medieval Europe, used gravity's constant pull on grains of sand to mark spans of time. Unlike sundials, it worked in darkness. Unlike water clocks, it resisted evaporation and freezing. The flow of sand was not perfect, yet its steady trickle embodied the metaphor of time as something slipping away, grain by grain, irreversible. Even flame was recruited into the service of time candle clocks, marked with measured lines, burned at relatively predictable rates. Some civilizations used graduated oil lamps for the same purpose. Here fire, the element of transformation, became a metronome of change. Each of these inventions was born not only from curiosity, but from necessity. Agriculture required schedules of planting and harvest. Empires required calendars for taxation and administration. Rituals required precise moments of observance. And as societies grew more complex, so too did their desire to command the flow of the invisible. Measurement transformed time into something people believed could be controlled. The sundial divided a day into hours. The clepsydra divided an hour into smaller spans. The hourglass gave sailors and monks tools to organize labor. Prayer and navigation time, once only a rhythm, now became a resource to allocate, a ruler against which life could be disciplined. But beneath these advances lingered an unresolved paradox. Were these instruments measuring time or only the motion of matter under natural laws? The sundial did not measure time itself. It measured the Earth's rotation and the sun's apparent motion. The water clock did not measure a flow of time. It measured the fall of water under gravity. The hourglass recorded grains moving through a narrow passage, not a hidden current of existence. Every clock was, in truth, a measure of change. And from that change, humans inferred the passing of something deeper, something invisible. This tension echoes through the centuries. Is time something real, flowing, independently of motion? Or is it only the name given to change once it is measured? Philosophers of antiquity pondered this quietly. Even as engineers refined their instruments, Aristotle saw time as the measure of motion, not as an entity itself. The Stoics described time as incorporeal, a framework in which the cosmos unfolded. And yet, for the daily life of farmers, priests, rulers, and travelers, these instruments transformed reality itself. For the first time, hours could be assigned, tasks scheduled, labor divided with mathematical regularity. The cultural transformation was immense. The Egyptian division of daylight into 12 segments, based on the movement of the sun, later combined with Babylonian astronomical traditions to produce a 24-hour day. From this fusion of astronomy, ritual, and technology, the skeleton of modern timekeeping emerged. Time was no longer simply experienced, it was standardized, coordinated across temples, fields, and palaces. And though these early hours varied with the seasons, the hours of summer were longer than those of winter. They represented humanity's first attempt to create an artificial frame that sat above the natural rhythms. The sundial's shadow, the water clocks dripping, the candles flame, the hourglasses trickle. Each was a metaphor as well as a tool. They taught people to think of time as something external, as something to be watched and recorded, rather than merely lived. They instilled the belief that time was linear, divisible, and, above all, measurable. But the paradox remained unresolved. If all these devices simply count motion, what is motion itself tied to? Is time the stage upon which motion occurs? Or is time nothing but motion seen through human eyes? Without these instruments, time had been lived as a pulse, a story, a cycle. With them, time began to appear as a measurable river flowing forward, external and absolute. The birth of measurement did not solve the mystery of time. It deepened it, for every attempt to trap time within glass, water, flame, or shadow revealed the same truth. The universe offers only change, and from change, humans construct the illusion of flow. As civilizations entered the classical age, this question would only grow louder. The philosophers of Greece, the astronomers of Alexandria, the mathematicians of India, all inherited the tools and the paradox of time. They would refine calendars, chart eclipses, and predict the return of comets. But the deeper question, whether time was truly being measured or whether only motion and memory were being counted, remained unanswered. The sundial's shadow may fall across stone. The clepsydra's water may drip into the night. The hourglass may release its final grain, but the essence of time itself would continue to evade capture. Measurement had given humanity the illusion of mastery. Yet mastery of shadows is not mastery of what casts them. The story of time had entered a new phase. A phase where instruments could divide the day into hours, and the hour into minutes, but the question lingered, silent and unsolved. Was it time that humanity had measured, or only the ceaseless dance of matter under laws it did not yet understand? For thousands of years, the movements of stars, the dripping of water, and the flicker of flame were humanity's only clocks. But in the 17th century, a profound shift began. The rhythms of nature were no longer just guides for ritual and survival. They became subjects for experiment, questions for mathematics, puzzles for a new kind of curiosity. It was Galileo Galilei, in the late 1500s, who first noticed something extraordinary. As legend tells, he sat in the great cathedral of Pisa, watching a bronze lamp swing on its chain. With each sway, he measured the rhythm against his own pulse. The arc of the lamp grew shorter as the motion slowed, yet the duration of each swing remained nearly the same. This property, called isochronism, revealed a strange regularity hidden within motion. The pendulum, unlike water or sand, did not flow away or scatter into chaos. It kept time with a precision that seemed carved into the geometry of nature itself. Galileo envisioned pendulums as tools to regulate clocks, devices that could impose consistency upon the measurement of hours. Though he never built a working pendulum clock, his insight opened the door to a new era. Time could be abstracted, extracted from nature, and entrusted to the logic of mechanics. In this awakening, measurement was no longer symbolic or mythic. It was becoming mathematical. Isaac Newton carried the transformation further. In 1687, with the publication of Philosophia Naturalis Principia Mathematica, time itself entered the realm of universal law. Newton described time not as a rhythm tied to sun or sand, but as something absolute. He wrote of absolute true and mathematical time, of itself and from its own nature, flowing equably without a relation to anything external. In Newton's universe, time was a silent stage on which the play of motion unfolded. It did not depend on planets or pendulums. It existed everywhere, the same for all observers, flowing steadily from eternity, past to eternity future. This vision allowed him to write the laws of motion, to describe the orbits of planets, the falling of apples, the rise and fall of tides. Equations that linked force, mass, and acceleration required a constant background, and that background was time itself. The mathematics worked from it. Astronomers could predict eclipses, chart comets, and calculate the mechanics of the solar system with astonishing accuracy. For the first time in history, time was not just measured, it was written into the very laws of physics. But Newton's time carried an unsettling shadow. It was unobservable. No clock could ever reveal absolute time. Every pendulum swung under the pull of gravity. Every watch ticked according to its own mechanism. All could be disrupted, sped, or slowed by forces of nature. Yet Newton's time was supposed to remain untouched, flowing identically everywhere in the universe. It was an assumption, invisible and eternal, invoked to make the mathematics work. The paradox sharpened. If absolute time could never be detected, did it exist at all? Or was it only a convenient invention of the human mind, a scaffolding built to hold equations in place? Even in Newton's own century, philosophers hesitated. Leibniz, the German polymath, argued against Newton's absolute stage. To him, time was relational. It was not an independent river flowing through space, but merely the order of events, the relation between one change and another without motion. Without sequence, time would have no meaning. In this view, Newton's absolute time was a fiction, a shadow with no substance. This debate cut to the deepest of questions. Was time real, existing apart from the world? Or was it only a pattern born of events? Newton's vision gave humanity extraordinary predictive power, but it also committed science to a concept that could not be proven. The centuries that followed would embrace Newton's absolute time. Clocks grew more precise. Pendulum designs refined by Christian Huygens in the 1650s achieved unprecedented accuracy. The synchronization of time allowed navigation across oceans, enabled the coordination of expanding empires, and gave industry a new rhythm of efficiency. The mathematical stage of Newton's vision became the unseen foundation of modern civilization, yet the philosophical tension remained. If time was absolute, why could it never be touched? Why was it always inferred from motion, never measured in itself? Even as science thrived on Newton's assumption, the unease lingered in the minds of those who sought deeper truths. Some saw in absolute time a theological echo, a divine clockmaker who set the universe in motion and let it unfold upon the stage of eternity. Others saw in it a necessity of reason, a background that gave order to chaos. But skeptics continued to whisper, what if time had no existence of its own? What if all that could ever be measured were motions, changes, sequences, and nothing more? The scientific awakening of the 17th century was therefore double-edged. It gave humanity the power to describe the cosmos with unprecedented precision. It allowed laws to be written in mathematics, predictions to be confirmed in observation, and technology to expand beyond imagination. Yet it also anchored the concept of time in a paradox, a background that could be calculated but never seen, an invisible current invoked but never captured. The pendulum swung in its steady arc, and in that arc, humanity glimpsed the possibility of certainty. Newton's equations unfolded across the heavens, and in them, humanity glimpsed a universe ruled by order. But beneath both pendulum and equation lingered a silence that asked whether what was being measured was time itself or only the endless transformations of matter. The awakening was real, but it did not end the mystery. It only deepened the question. Is time a stage, absolute and eternal? Or is it nothing more than the sequence of changes, remembered and recorded by minds that search for meaning in the flow of motion? The answer would wait for centuries more, until Einstein tore down Newton's absolute stage and revealed a cosmos stranger than either Newton or Galileo could ever have imagined. In the early years of the 20th century, the universe's most trusted clock began to falter. For more than 2 centuries, Newton's vision of an invisible river of time had served as the backdrop against which every law of motion was written. Time was thought to be absolute, steady, and universal, flowing evenly for all, no matter where in the cosmos they stood. But in the quiet mind of a patent clerk in Bern, that certainty began to fracture. Albert Einstein's insight was as simple as it was devastating. The universe does not keep a single universal rhythm. Instead, each observer carries a private clock, a personal tempo shaped by speed and by gravity. In the relativity of time, Newton's absolute stage dissolved into something stranger and far more elusive. The idea began with light. Einstein asked, what if the speed of light was the same for all observers, no matter how they moved? The mathematics, when unfolded, made an astonishing demand. Space and time, once thought independent, had to be woven into a single fabric. To keep light steady, time itself had to bend. The consequences rippled outward like shockwaves through the history of thought. If two twins parted ways, one traveling into the cosmos at near light speeds while the other remained on Earth, the one who journeyed would return younger. Their bodies, their minds, their very experiences of reality would no longer align. This twin paradox was no mere puzzle of imagination. It was a glimpse into the pliability of time. The concept of time dilation soon left the chalkboard and entered the laboratory. In 1971, physicists Joseph Haefel and Richard Keating boarded commercial aircraft carrying atomic clocks of extraordinary precision. They flew eastward around the Earth, then westward, while other clocks remained on the ground. When compared, the clocks disagreed. Minutes and seconds had flowed differently depending on velocity and direction of travel. The experiment confirmed what relativity foretold. Time does not beat with one drum, but many. The effect is subtle at ordinary speeds, but grows profound in the extremes. A clock on the peak of a mountain, where Earth's gravity is slightly weaker, ticks faster than a clock at sea level. Satellites orbiting high above us carry instruments that must account for this difference every moment. Without adjusting for relativity, the global positioning system would fail within hours. Its signals adrift in mismatched time. Each map, each navigation, each journey through the modern world quietly depends on Einstein's vision. Yet relativity is not merely practical, it is unsettling. It tells us that time is not a river carrying all boats at once, but a current that bends and stretches depending on the weight of gravity and the speed of motion. There is no single now across the universe. A star on the edge of a distant galaxy does not share the same present as Earth. The concept of simultaneity, once obvious, dissolves into relativity's haze. This realization fractured more than equations. It fractured intuition itself. If time depends on where one stands and how one moves, then what becomes of the human instinct to believe in a shared moment? What is the present when billions of presents coexist, layered and offset like a shifting mirage? Philosophers struggled with the implication. If time is relative, does it even exist as an independent entity? Or is it nothing more than a measure of change, a coordinate within space-time that has no flow of its own? Einstein himself leaned toward the latter. In letters written late in life, he reflected that the distinction between past, present, and future was only a stubbornly persistent illusion. And yet, the illusion endures. Each heartbeat, each breath, each flicker of memory feels carried forward by something. Relativity does not erase that sensation. It only shows that the sensation is local, private, irreducibly tied to perspective. Experiments have only deepened the mystery. Particle accelerators reveal subatomic lives stretched and elongated by speed. Muons, unstable particles created high in the atmosphere, should decay in fractions of a microsecond, yet moving near light, their internal clocks slow, allowing them to reach the ground before disintegrating. The cosmos itself keeps proving relativity correct, but for all its triumphs, relativity leaves an aching question unanswered. If time is not absolute, if it splinters and bends, what then is the reality beneath? What is the substance of time before it is measured? Is it a physical dimension, stitched into the very geometry of space-time? Or is it a phantom, an emergent, phenomenon born from relationships between events? The Einsteinian revolution gave science tools to predict, to measure, to harness, but it also deepened the enigma. Time was no longer a background, but neither was it fully understood. It became a participant, a player in the cosmic drama, inseparable from motion and mass. And so, the age of absolutes ended. In its place stood a universe far more complex, a universe where every tick of every clock is personal, where every path through space-time is unique, a universe where time itself could not be trusted to remain the same from one observer to another. The revolution was complete, but it was only the beginning. For if time could bend, if it could differ from one vantage to another, what other secrets might it conceal? What deeper fabric might lie beneath, still hidden, waiting for the next fracture in human understanding? The questions remain suspended, like stars over an endless horizon, and time itself, elusive, fractured, yet undeniable, continues to guide all things forward, though never quite the same for any two. Time had been fractured once by relativity, but now, in the 20th century, another fracture appeared, one deeper, stranger, and more resistant to repair. For as physicists turned their gaze from the stars to the smallest quanta of reality, they discovered that time, the silent thread they believed to be universal, refused to behave like the rest of nature. In the realm of quantum mechanics, space and time are not equals. Space can ripple, twist, and bend. A particle can blur. Across it exist in many places at once, tunnel through barriers, or vanish into the haze of probability. But time flows only forward. In Schrödinger's equation, the central mathematical engine of quantum theory, there is always a T. It ticks forward with metronomic regularity, driving the unfolding of probability waves. It acts as a silent stage manager, steady and unquestioned. Yet relativity had already told us there is no universal clock. Time does not beat the same everywhere, but bends with motion, with mass, with gravity. The equations of Einstein refuse to admit any single rhythm, any master metronome. And here lies the paradox. Quantum mechanics demands a fixed time against which all motion is measured. Relativity declares no such thing exists. Two great theories, the pillars of modern physics. Staring at each other across a gulf, neither can cross. This conflict is sometimes called the problem of time. It is not just a technical nuisance, but a philosophical wound, one that goes to the heart of what reality is. In quantum theory, the electron in its cloud does not know yesterday or tomorrow. It only knows the present instant and the probabilities of what might unfold next. But relativity insists that past, present, and future all coexist, woven into the fabric of space-time itself. Which is real? The block universe of relativity, where every event already exists, waiting like a page in a finished book. Or the flowing present of quantum mechanics, where the future is undefined, and only when observed does the haze of potential collapse into reality? Physicists have tested these boundaries again and again. Experiments in quantum entanglement suggest particles can share correlations across space instantaneously, as if space itself is not the stage we thought it to be. But still, even in these experiments, time flows forward. Decoherence, the process by which quantum superpositions collapse into classical states, always unfolds in a temporal order. It is irreversible, carrying an arrow. Some have argued that this arrow of time is born not from the equations themselves, but from entropy, the statistical drift from order to disorder, from the collapsing of stars, the spreading of gas, the shattering of symmetry. Entropy provides a direction, a slope upon which all things roll. Yet entropy is not fundamental. It is emergent, a summary of countless microscopic arrangements. So the arrow of time may itself be a mirage, a shadow of deeper laws we cannot yet see. There are proposals that seek to reconcile the split. So quantum gravity, a theory not yet complete, Some physicists imagine that time itself may not exist fundamentally. Instead, time may be emergent, like temperature, a property that arises only when countless microscopic interactions are taken. Together, Carlo Rovelli, one of the architects of loop quantum gravity, has written that at the deepest level, the universe may be timeless, that the flow of moments is not written into the equations of reality, but is instead a feature of how limited creatures, like humans, perceive change. To us, the world must appear as a sequence, but to the cosmos, perhaps all is one vast interconnection without beginning or end. And so the question emerges, did the universe experience time before there was mind to count it? Was there a before the Big Bang, or does that word lose meaning when the very stage of time dissolves? In physics today, this question remains unresolved. The mathematics of relativity, tested in the dance of galaxies and the bending of starlight, refuses to let go of its four-dimensional space-time. The mathematics of quantum mechanics, tested in the precision of atomic clocks and the structure of every atom, refuses to let go of its ticking parameter of time. Some argue that the future of physics will demand an entirely new conception, one in which both views collapse into a deeper symmetry, a law beyond human intuition. Others believe the fracture is telling us something profound, that time, the most intimate of human experiences, is not woven into the universe at all, but born only in the act of perception. For now, the paradox endures. Every experiment conducted in the laboratories of Earth reveals pieces of the puzzle. Atomic clocks confirm relativity's prediction. Time stretches in orbit, contracts on the ground. Quantum mechanics confirms its prediction. Particles evolve in probability space, guided by a time that never falters. Both are true, both are indispensable, and both, when joined, refuse to agree. It is a paradox that sits at the core of physics, a riddle as deep as any in human thought. The problem of time is not just a technical barrier on the path to a theory of everything. It is a mirror held up to the human mind, reminding us that what seems most familiar, most obvious, may be the greatest illusion of all. And so, in the quiet of this fracture, another question lingers. If time is not fundamental, then what is this river through which we drift? And if the river is not real, then what are we? The human imagination often reaches backward, further than memory, further than the written word, to the very beginning of all beginnings. But when the question of time itself is raised, when it began, and if it began at all, science enters, a territory both fragile and profound. Modern cosmology suggests that the universe, as it is known, was born 13.8 billion years ago in an event called the Big Bang, not an explosion into space, but the birth of space itself, not fire expanding into emptiness, but emptiness itself unfolding, carrying with it the seeds of galaxies, the ripples of future stars, and the framework of what humans call time. In this picture, time is not eternal. It is not a silent river stretching infinitely in both directions. Instead, it has a bank, a beginning, a shoreline, where the flow seems to rise out of nothing. The mathematics of general relativity points to a singularity at this origin, a place where densities rise beyond measure and equations fracture. In that singular moment, the idea of before seems to lose meaning, because before is itself a concept woven into time. And if time was born in the Big Bang, then the very question of what came before may dissolve into paradox. The philosopher Augustine, centuries before telescopes, whispered a similar hesitation. When asked what God was doing before the creation of the world, he replied that time itself was created with the heavens and the earth, that there was no before creation, because time did not exist yet to measure such a before. What was once theology becomes, in modern physics, a strikingly parallel question. What does it mean to speak of a time before time? Quantum theory attempts to offer clues. Some physicists imagine a foam, a restless sea of energy, flickering at scales too small to visualize. In this foam, the distinction between past and future may blur. There may not be a universal ticking at all, only transitions between uncertain states. Here, the seeds of space and time themselves might arise spontaneously, bubbling out of nothingness, not as an event in time, but as the very birth of time's possibility. Stephen Hawking offered a proposal known as the no-boundary condition. In this vision, time near the origin does not end in a singular edge, sharp and abrupt. Instead, time bends, curves smoothly like the surface of a sphere. To ask what lies before the beginning is like asking what lies north of the North Pole. The question itself loses footing. Time becomes finite, but unbounded. It has a shape, but not an edge. This proposal, though elegant, remains untested. It invites reflection as much as calculation. If time curves into itself at the birth of the universe, then the universe has no first instant, no absolute dawn. It simply is eternal, not in duration, but in completeness. Cosmic time today is measured against the rhythm of expansion itself. The redshift of distant galaxies marks the stretching of space, the widening of the cosmic fabric. This expansion acts as the universal clock, the measure by which the universe ages. 13.8 billion years since that unfolding began. But what those numbers conceal is the abyss lying beneath. For they trace the river of time only after it begins to flow. They do not reach into the dry bed where the river first appeared. Physicists struggle with this paradox. Relativity, which describes the geometry of spacetime, predicts a singular beginning. Quantum mechanics, which governs the very small, denies the possibility of such infinities. When the two are brought together, their languages clash. One insists on a beginning of time. The other suggests that beginnings may be illusions, artifacts of incomplete mathematics. Some hypotheses whisper of a universe that emerges from a timeless state, not from nothing, but from something deeper than time. Perhaps a quantum vacuum pregnant with potential in which all possible histories coexist. In this view, the universe does not begin but crystallizes, selecting a path out of many. And with that selection, time itself is born, like the first note of a song breaking silence. Yet silence remains a dangerous metaphor, for silence implies duration, and duration is already time. The more deeply the question is pressed, the more language breaks. Physics begins to resemble poetry, caught at the edges of what can be said. Time before clocks, time before stars, time before thought. What did it mean for anything to happen when happening itself had not yet been born? Even in the present, echoes of this mystery remain embedded in the universe's cosmic background radiation. Faint microwaves arriving from every direction in the sky carries the memory of a time when the universe was young, less than 400,000 years after its beginning. This light is ancient, but it does not reach back far enough. It is not the voice of the beginning itself, but the first whisper that could travel freely through space. Before that whisper, the cosmos was opaque, a glowing plasma, the details of which lie hidden behind the veil of time's earliest chapters. Future observatories may probe further, perhaps by detecting primordial gravitational waves, ripples in spacetime itself, stirred in those first instants. If they are found, they could reveal whether time began in a singular burst or in a smoother curvature without boundary. But until then, the beginning remains both scientific and philosophical terrain, a frontier where equations collapse into mystery and mystery feeds back into equations. The question returns, hauntingly simple, impossibly deep. Did time begin 13.8 billion years ago, with the Big Bang? Or is the universe older than time itself, a timeless ocean from which time only emerges, like foam on a restless tide? Physics has not yet answered, it may never answer fully. for every clock that ticks in laboratories, every pulsar that spins in distant galaxies, every second that falls away in human lives, all of them are measured after the beginning. Not one of them can testify to what it meant for beginning to begin. In the silence before clocks, before instruments, before any observer to call it time, the universe may have known only the possibility of becoming. Whether that possibility was infinite or fleeting, singular or cyclical, remains unknown. And so, the origin of time itself continues to cast its shadow across science, not only as a technical puzzle of physics, but as a philosophical abyss into which thought itself falls. Time, before clocks' time, before us, the first mystery, and perhaps the last. In the quiet mathematics of physics, time is a variable that can run forward or backward, without preference. But in the lived universe, time insists on a direction. It flows like a river that never reverses, carrying all things from past to future, from birth to decay. The mystery lies not in the equations, but in entropy. Entropy, in the language of thermodynamics, is disorder. Not the simple mess of a room or the scattering of papers on a desk, but the deeper statistics of arrangements, the countless microscopic ways particles can configure themselves. A crystal, aligned and rigid, is low in entropy. A cloud of vapor, diffuse and chaotic, is high in entropy. And the universe, with every tick of its unseen clock, drifts toward greater disorder. This drift defines the arrow of time. It is not the ticking of a clock that gives time its direction, nor the orbit of planets around the sun, nor the swing of Galileo's pendulum. It is entropy that tells the universe which way to march. Without it, the past and the future would dissolve into symmetry, indistinguishable mirrors of one another. The memory of yesterday and the anticipation of tomorrow would collapse into a featureless blur. This truth was first glimpsed in the 19th century, when Ludwig Boltzmann connected thermodynamics with probability. He saw that order was unlikely and disorder inevitable. The second law of thermodynamics, which states that entropy tends to increase, became more than an engineering principle of steam engines. It became a law about the fate of everything. Entropy is why ice melts, but never spontaneously refreezes in a warm room. It is why smoke disperses, but never gathers back into the neat spiral of a candle flame. It is why life grows, ages, and fades. Entropy makes time irreversible. And yet, the arrow it draws is not uniform across all scales. At the quantum level, the equations of physics remain reversible. A photon scattering from an atom could, in principle, be played backward without contradiction. It is only when systems grow large, when billions of particles interact, that the irreversibility emerges. The arrow of time is not in the fundamental laws, but in the statistics of vast collectives. It is an emergent property of the universe itself. This realization deepens the paradox. If entropy defines time, then why was the early universe so low? In entropy, the Big Bang, though unimaginably hot and dense, was astonishingly ordered. Galaxies had not yet scattered. Black holes had not yet devoured stars. Randomness had not yet taken hold. The cosmic beginning was a strange state of improbable order. The seed of every arrow of time that followed physicists wrestle with this puzzle. Why should the universe begin in such an unlikely condition? Some argue that entropy itself is cyclical, that in a multiverse, pockets of low entropy continually arise like oases in a desert of timelessness. Others suggest that time itself might be an illusion of entropy, not a fundamental dimension, but a bookkeeping of change. Stephen Hawking once wondered if the universe simply exists in the most probable state, and what we call time is the way entropy makes that probability unfold on Earth. Entropy is both intimate and inescapable. It defines the rise and fall of civilizations as surely as it governs the cooling of stars. Every building crumbles, every organism decays, every thought fades into memory. Even in human history, Entropy reveals its arrow. A library burns in Alexandria, and the knowledge scatters like smoke, never to be reassembled in its perfect form. An empire falls, and its order gives way to centuries of chaos before a new structure can emerge. Entropy is not only the fate of molecules, but of cultures, languages, and lives. And so, entropy's arrow is also mortality's arrow. To feel the passage of time is to feel the advance of disorder within the body cell's age. DNA accumulates errors. The complex order of life drifts toward dissolution. Entropy is the ticking clock of existence, the silent metronome of decline. It is the reason memory is possible, because the past leaves traces in a universe moving from order to disorder. It is the reason anticipation is possible, because the future remains open, the entropy not yet written. The arrow of time, therefore, is not drawn by the heavens, but by the irreversible tendency of disorder. It is not imposed from outside, but emerges from within. The stars burn down, the galaxies drift apart, and heat spreads until no gradient remains. This vision leads to the ultimate fate known as heat death. A universe where entropy reaches its maximum, where no energy difference exists to power motion, thought, or life. A cosmos where time itself may lose its meaning because nothing more can change yet in the present. Entropy is not only a destroyer, but also a creator. It allows complexity to emerge in the brief interval between order and decay. Stars form from collapsing clouds, fueled by gravitational gradients that increase entropy overall. Life emerges from flows of energy, sustaining itself temporarily against the tide. Even human civilization, with all its art and science, exists because energy gradients allow work to be done. Even as entropy rises in the background, creation and destruction, birth and death, both flow along entropy's one-way river. In this sense, entropy is not merely a law of physics, it is the author of history. It is the silent rhythm beneath galaxies, beneath lives, beneath thoughts. It gives time its direction, gives memory its anchor, and gives mortality its inevitability. The arrow of entropy is the arrow of time, and humanity, like every star and every particle, moves inexorably along its path. But the question remains, is this arrow fundamental, or is it a temporary feature of a universe still young? If the cosmos is infinite, if it cycles endlessly, might entropy itself have reversals, hidden chapters where order can emerge anew? Or is entropy the ultimate truth, the final silence into which everything dissolves? The answers lie beyond the reach of present science, but the paradox endures. Without entropy, time would be meaningless. With it, time is a river that no force can stop. The universe remembers because disorder grows. The universe dreams because order fades. The arrow of time is entropy's gift and entropy's curse. It is the measure of life and the measure of loss. It is the ticking, silent, unstoppable clock that began long before humans and will continue long after they are gone. Long before sand fell through glass, before pendulums swung, before the first human hand carved a tally on stone, the cosmos itself was already keeping time. Not with gears, nor with dials, but with its own rhythms, vast, unbroken patterns written in starlight, in atoms, in gravity itself. These are clocks without hands, instruments forged not by human invention, but by nature's enduring pulse. In the silence of space, one of the most reliable of these natural clocks reveals itself, the pulsar. Born from the death throes of a massive star, a pulsar is the collapsed remnant of a supernova, its mass squeezed into a sphere barely the size of a city. Magnetic fields twist violently around it, and jets of radiation burst outward from its poles. As it spins, it flashes with extraordinary precision, beams of light sweeping across the cosmos like the beacon of a cosmic lighthouse. The pulses arrive with such regularity that they rival the best atomic clocks on Earth. Some rotate hundreds of times per second, each cycle marked with almost unimaginable accuracy. Astronomers have come to rely on them not just as stars, but as timekeepers, as if the universe itself had planted ticking hearts across the night sky. When civilizations on Earth were still learning how to measure seasons, these pulsars were already marking milliseconds with perfect discipline. Another natural chronometer lies hidden within matter itself, the slow, inevitable process of radioactive decay. Certain atoms are unstable. They break down with predictable half-lives, ticking away invisibly across eons. Uranium transforms into lead, potassium into argon, each with its own rhythm, its own tempo set by the laws of quantum mechanics. These half-lives can stretch across billions of years. They allow scientists to measure the age of rocks, of fossils, of the Earth itself. Every grain of zircon crystal on the planet holds within it a silent record, a radioactive heartbeat that has never skipped, never faltered, not once since the birth of the mineral. Through these clocks, geologists discovered that the Earth is 4.5 billion years old, an age not guessed at, but read from the steady patience of atoms. Here, time is not something observed. It is embedded into the matter of the world itself. A universe that seems fleeting in human terms reveals, through radioactive decay, its deeper patience, its long memory. And then, there is the grandest of all clocks, orbital mechanics. The Earth circles the Sun, the Moon circles the Earth, the planets dance their slow trajectories through the solar system. Every orbit is a revolution, a return, a natural hand sweeping across the dial of the sky. Long before the concept of seconds or hours existed, humans could look upward and notice the steady path of the moon across the heavens. The cycle of phases marked months. The journey of the sun across the horizon marked seasons. Our earliest calendars were not inventions so much as recognitions. They were acknowledgements of rhythms that had existed long before us, rhythms woven into the fabric of celestial mechanics. Even now, orbital dynamics remain one of the universe's deepest measures. From the movement of stars in the Milky Way, astronomers can trace how galaxies formed, how gravity bound clusters together, how time has unfolded on scales vast beyond comprehension. But perhaps the most profound lesson of these natural clocks is that they reveal time as an objective presence, something the cosmos carries in itself, regardless of whether any mind observes it. Pulsars would have pulsed even if no eye had seen them. Atoms would have decayed even if no geologist had measured them. The Earth would still have circled the Sun, even if no species had ever walked its surface. These rhythms tell us that time is not conjured by human instruments. Clocks do not create time, they only interpret it. They are the shadows of deeper cycles, the reflections of movements that were ancient before humanity, and will continue long after humanity is gone. And yet, there is something haunting in this realization. Because when the stars serve as clocks, they are not counting for us. Their rhythms are indifferent. A pulsar's tick is not a message, but a byproduct of collapse. The orbit of the Earth does not notice our calendars. Entropy does not pause for memory. The universe keeps time, but not in any way that recognizes us. Its clocks have no faces, no hands, no chimes. They mark the passing of eras without ceremony. A second to a pulsar is not more or less than a billion years to a galaxy. Each system counts at its own pace, like countless overlapping songs without a conductor. Through them, astronomers have pieced together the age of the cosmos itself. By measuring the faint background radiation left over from the Big Bang, they discovered another kind of cosmic clock. This radiation, stretched and cooled as the universe expanded, now fills all of space at a temperature of just 2.7 degrees, above absolute zero. Its faint microwave glow is a fossil signal, a snapshot frozen from a time when the universe was only 380,000 years old. By studying the patterns in this radiation, cosmologists have dated the universe with remarkable precision. 13.8 billion years. This is not an arbitrary number. It is a reading, taken from the universe's own instruments. The cosmos carries within it the records of its past, etched not in ink, but in starlight, in radiation, in the decay of atoms. And so, time before us was not empty, not unmarked. It was written in neutron stars, in orbits, in the silent countdowns of radioactive decay. The cosmos had been keeping its own records long before human civilization awoke to wonder about them. The stars themselves had been ticking the hours, even before there were eyes to notice, even before there were minds to imagine what an hour meant. In the end, human clocks are only translations, fragile attempts to catch echoes of rhythms that belong to the universe itself. The deeper truth is that the cosmos has always carried its own time. We only stepped into its flow, late and uninvited, learning to read what was already there. There is a question that lies at the edge of science and philosophy, a question that dissolves the very ground beneath human thought. What if time itself does not exist? The suggestion seems absurd, almost heretical, for every life is measured in its passing, every memory bound by its order, every heartbeat tied to what comes before and what must come after. Yet among physicists, the idea has emerged that time, this most familiar of dimensions, may not be fundamental at all. Julian Barber, a British physicist, has given this vision its most striking form. In his writings, the universe is not a river through which reality flows, but an ocean of stillness. Within it, every possible moment, every now, exists, whole and complete. What humanity perceives as the movement of time is, in this picture, nothing more than the mind-stitching still frames into a film, a perception born of memory, not a property of the universe. This vision, called timeless physics, overturns the most basic assumptions. It suggests that the past and the future are illusions of perspective, and that only the eternal present is real. In such a cosmos, the child is not becoming the adult, nor the star becoming the supernova. Both exist, side by side, without sequence, without unfolding change. In this view, is not a process, but a comparison between one frame of the universe and another. This picture finds echoes in another radical idea, born from relativity, the block universe. Here, space-time is a four-dimensional structure, already complete, unchanging, eternal. Every past, present, and future event exists together, like pages bound in a book that has already been written. From the birth of the first star to the final flicker of the last black hole, all is there, coexistent, waiting to be read. What humans call the flow of time is simply the way consciousness moves across this block, like a spotlight sliding across a frozen landscape. And yet, if the universe is timeless, why does it feel otherwise? Why does the arrow of experience point forward, always forward? Some theorists turn to quantum mechanics, to the strange interlocking of entanglement and information. In certain approaches to quantum gravity, time is not a starting point but an emergent property, arising when quantum systems interact and correlate with each other. In this telling, time is not a container in which the universe exists. It is a shadow, cast by the structure of relationships. Between particles and fields, it is born from complexity, from entanglement, from the growth of correlations that allow one thing to be remembered against another. The timeless hypothesis, then, asks humanity to imagine that clocks do not measure an external reality, but only help construct the illusion of flow. Seconds and minutes, in this frame, are not slices of an underlying continuum. They are agreements, human interpretations, projections onto something that does not move at all. The implications are vast, unsettling, almost unthinkable. If time does not exist fundamentally, then the Big Bang is not a beginning, but a point among other points. If time is emergent, then before and after are not eternal truths but human categories. In such a universe, to ask what happened before the birth of the cosmos is to misuse language itself, for there is no before. There is only the totality of existence, silent and complete. And yet, the mind resists. It resists because memory tells stories in sequence, because the body feels the weight of aging, because loss is measured in hours and joy in moments. To strip time from the universe feels like stripping breath from life, but science has always pressed against the comfortable. And here, it presses most deeply of all. Consider this paradox. If the block universe is real, then every moment of every life already exists, not vanished, not lost. The first cry of an infant, the last whisper of the dying, the birth of civilizations, their collapse into ruins, all persist, forever inscribed in the geometry of space-time. The past is not gone. The future is not waiting. Both are already there, as real as the present in which these words are spoken. This view, unsettling though it is, carries a kind of strange comfort. In a timeless cosmos, nothing is truly erased. What is loved is never unmade, only fixed in its place in the grand structure of being. The arrow of human perception may march forward, but the totality holds every step at once. And yet another vision challenges even this. Julian Barber's nows need no block, no space-time at all. Instead, each configuration of the universe simply is. The cosmos is a gallery of frozen instants, unconnected, timeless. What seems like motion, what seems like cause and effect, is only the mind weaving continuity across these scattered jewels of reality. In this view, time does not flow because there is no river to flow upon. There is only the shimmer of stillness, mistaken for motion by creatures who carry memory within fragile neural networks. This is not mysticism, but physics, born of attempts to reconcile quantum theory with relativity. Both great pillars of modern science break upon the question of time. Schrödinger's equations, Einstein's space-time, thermodynamic arrows. None agree fully on what time is or whether it exists at all. Perhaps, in the next great synthesis, time itself will vanish, revealed as an approximation, a mirage, and so the question lingers, unanswered but unavoidable. Is time real, or is it the greatest illusion ever conjured? If it is illusion, then mortality itself changes its meaning. For what humans call death may not be a departure into nothingness, but simply the resting of the spotlight upon a different part of the block. A shift in focus, not an erasure of existence. The timeless universe hypothesis is more than a scientific speculation. It is a mirror held to the deepest fears and longings of the human spirit. For if time does not exist, then every moment is eternal. But if time does not exist, then the very story of existence, of becoming, of change, of evolution, is nothing more than the dream of a dreaming universe, in the silence of the cosmos, where no clocks tick and no calendars turn. Perhaps time is not missing at all. Perhaps it was never there to begin with. Only the vast, still ocean of being, stretching without beginning or end. And within it, the fleeting minds of humankind, weaving threads of memory into the illusion of flow, believing in hours and years, while the universe itself remains timeless. Time, once marked by shadows on stone and the turning of the heavens, is now measured with instruments of staggering precision. Humanity has built machines that can divide a single second into 1 billion fragments, and then divide those fragments again. At the heart of this mastery stand atomic clocks, devices so precise that they lose less than 1 second over the entire age of the universe. They do not count minutes in the way an hourglass does, nor do they tick like the gears of a pendulum. Instead, they listen to the very heartbeat of atoms. Cesium and strontium atoms, vibrating with a rhythm dictated by the laws of quantum mechanics, become nature's ultimate metronomes. Each oscillation is identical, unchanging, immune to the passage of ordinary wear. When scientists say a second has passed, what they mean is that a cesium atom has completed exactly 9,192,631,170 vibrations. Time itself, in the language of physics, is pinned to this atomic pulse. But even this definition reveals a subtle paradox. For the universe does not produce seconds on its own. Seconds are a human choice. a convenient measure we attach to nature's rhythm. The atoms do not know they are keeping time. They simply exist, vibrating in silence, while humanity interprets them as clocks. Above the Earth, a constellation of satellites circles endlessly. The Global Positioning System, a network of metal spheres drifting in orbit, does far more than guide travelers across roads and oceans. Each satellite carries its own atomic clock, tuned with exquisite precision. Their signals, beamed down to Earth, allow receivers to triangulate position within meters. Yet hidden beneath this technological achievement lies one of the most profound confirmations of modern physics. For if those satellites ran on Newton's time, they would drift and falter. Their clocks tick differently from those on Earth because of Einstein's relativity. At high orbital speed, time itself slows down, and in the weaker pull of Earth's gravity, time speeds up. Left uncorrected, a GPS device would place its user miles from the true location within a single day. Only by adjusting for relativity, by acknowledging that time is not absolute, can the system function. Every journey made with GPS is a quiet testament to the fact that the flow of time bends with speed and gravity. And still, science has gone further. The Laser Interferometer, Gravitational Wave Observatory, or LIGO, was built not to track planets or atoms, but to sense ripples. In the very fabric of space-time, two arms, each 4 kilometers long, stretch across the Earth. Inside them, beams of laser light bounce back and forth between mirrors polished to perfection. The light returns in perfect synchrony, unless space-time itself trembles. When two black holes collide in the abyss of the universe, they send waves across the cosmos, expanding and compressing space-time as they pass. LIGO detects these waves not by sound or by sight, but by watching its laser clocks fall out of step. A shift smaller than the width of a proton tells the story of cataclysmic events billions of light years away. Humanity listens to the universe by watching how time itself is disturbed. It is here that irony emerges. With instruments so powerful they can hear black holes merging in the dark, science has begun to confront a deeper riddle. Perhaps time itself is not fundamental. The very tools built to measure time with impossible precision whisper of its fragility, suggesting it may be only an emergent property, not the bedrock of reality. In laboratories, physicists now pursue even more ambitious machines. Next generation, atomic clocks, using strontium lattices and optical frequencies, are reaching accuracies where the pull of Earth's gravity, even a shift of a centimeter in height, alters the measurement. A clock raised on a table ticks faster than one left on the floor. At this precision, time ceases to be a universal backdrop and becomes something local, intimate, and fragile. Some envision using these clocks to map Earth's gravitational field in astonishing detail, detecting subterranean flows of magma or the slow melting of ice sheets. Others dream of deploying them in space, where their delicate tick could serve as a probe into the fabric of the cosmos. In every case, the quest is the same: to measure time so deeply that it becomes a tool to interrogate reality itself. Yet, at the heart of this pursuit lies a haunting question. If time does not exist fundamentally, what are these clocks truly measuring? Are they revealing an objective flow written into the universe? Or are they only mirroring the rhythms of physical processes we have chosen to name as seconds? Julian Barber has argued that all these clocks are not ticking toward a future, but merely comparing one static arrangement of the universe with another. Others, working in the strange mathematics of quantum gravity, suggest that time may be nothing more than a byproduct of entanglement, an emergent illusion that arises when particles share information. If that is true, then every precision clock humanity builds is not measuring the flow of time at all, but merely translating the shifting patterns of existence into numbers on a dial. The second becomes not a unit of reality, but a reflection of perspective. And yet, there is an undeniable poetry in this pursuit. For millennia, humanity looked upward, measuring the day by the sun, the month by the moon, and the year by the stars. Today, the measure has shifted inward, into the hidden dance of atoms, into the trembling of light across mirrors, into the smallest fragments of space-time itself. Where once shadows marked the hours, now black holes and gravitational waves define the frontier of the clock. In these tools of the present lies both triumph and humility. Triumph, because never before has humanity wielded such power to measure, to predict, to navigate. Humility, because the more deeply we probe, the more tenuous the concept of time appears. Perhaps, in the end, these clocks are not devices to capture time, but mirrors reflecting our own need for order. They do not prove time's existence. They only prove our desire to find rhythm in a universe that may be timeless. Still, the work continues. Every pulse of a cesium atom, every synchronization of a satellite, every flicker of a laser beam tells us that humanity has reached into the fabric of the cosmos and tried to make sense of it. Even if time itself is an illusion, these clocks stand as monuments to the human quest to measure the immeasurable. For in the silence of the atom, in the vibration of light, in the trembling of space-time, the universe speaks, and humanity, with its tools of the present, listens, not knowing whether it is hearing the beat of time itself, or only the echo of existence unfolding. Time has always been more than equations, more than the quiet ticking of gears or the oscillations of atoms. Long before physics gave it symbols, time was lived in the blood and the breath, in the rise of the sun and the slow fall of the moon. It is not only an external rhythm written across the sky, but also an inner one, stitched into the fragile machinery of the human mind. For each person, time bends, stretches, and contracts. A moment of joy can slip past in a heartbeat, while a moment of grief can feel as though it lingers for an eternity. This fluidity reveals a truth that physics alone cannot contain. The experience of time is not the same as the measure of time. Neuroscience has begun to unravel this mystery. Within the brain, clusters of neurons fire in patterns that serve as rough internal chronometers. Experiments show that the basal ganglia and prefrontal cortex play a role in judging durations, while dopamine levels can distort these judgments, making moments feel elongated or fleeting. When dopamine surges, time can appear to speed up. When it falters, time drags. To the brain, time is not absolute. It is chemical, electrical, fragile. Even the heartbeat, steady and ancient, has long been one of humanity's inner clocks. Before sundials, before hourglasses, before atomic vibrations defined the second, there was the pulse in the chest. Early healers took this rhythm as a natural measure of passing moments. 100 heartbeats might span a ritual, a prayer, a moment of rest. The body, without knowing it, was counting. But experience also reveals the elasticity of time. In moments of fear, the amygdala sharpens memory and accelerates perception, so that fractions of a second feel magnified into longer spans. Survivors of accidents often recall that events seem to unfold in slow motion. Their brains, flooded with stress hormones, encoded more detail per second, giving the illusion that time itself had slowed. The opposite occurs in states of flow or joy. Hours of creativity, of music, of dance, can vanish in what feels like minutes. The brain, engaged and seamless, does not mark each tick of duration. It smooths over the passage, creating the sensation that time has dissolved. Philosophers have long wrestled with this tension. Augustine of Hippo, in the 4th century, admitted that he could not define time, though he felt it intimately. He wrote that the present alone seemed real, but even the present was fleeting, slipping away the moment it was recognized. To him, time was inseparable from consciousness. It existed not in the world, but in the soul's ability to remember and anticipate. Modern cognitive science echoes this thought. Some theories suggest that the perception of time is less about an external flow and more about the stitching together of memory. Without memory, the sense of duration collapses. A life lived without recall of yesterday or expectation of tomorrow would contain only a single, eternal moment. In this way, memory may be the true engine of experienced time. Cultures, too, have given shape to these perceptions. Ancient peoples often spoke of time as a cycle rather than a line. The Egyptians tied their sense of eternity to the Nile's floods. The Mayans charted vast repeating calendars where worlds ended and began again. In such visions, time was not an arrow pointing forward, but a wheel turning endlessly. Only later, in the modern scientific age, did time become fixed as a linear quantity, stretching from past to future. Yet even in the modern world, humans still feel time in ancient ways. Waiting in silence, minutes can feel unbearable. Watching a child grow, years can feel as though they pass in the blink of an eye. The clock measures each second evenly, but the mind does not. To live is to bend time inward, to stretch and compress it until it matches emotion. There is an irony hidden here. Physics can describe cosmic epochs, billions of years across, and can measure intervals shorter than a trillionth of a second. But in the end, each human life is lived in the fragile theater of perception. For the individual, time is not the age of the universe or the decay of isotopes. It is the memory of a summer afternoon, the quickening of the heart, the slowness of grief. Modern neuroscience continues to probe this tension. Studies of patients with temporal lobe damage reveal distortions in time perception so severe that days cannot be distinguished from minutes. Disorders such as Parkinson's disease, which affect dopamine circuits, alter the flow of time within the mind. To these patients, time does not march forward. It stumbles, hesitates, even falters. This raises a profound question. If time can be stretched and twisted inside human perception, is its passage truly external at all? Or is the sense of flow nothing more than a construct of the brain, an illusion shaped by memory and expectation? Quantum physics has already suggested that at the deepest level, time may not be fundamental. The timeless universe hypothesis and the block universe model propose that past, present, and future may all coexist. If this is so, then perhaps the human brain, in its limited capacity, assembles the illusion of flow from a timeless reality. Perhaps consciousness itself is the clock. What is certain is that before mechanical devices, before the splitting of seconds and the precision of cesium oscillations, time still moved in the human heart. Hunters watched the shadow of the sun glide across the earth. Farmers felt the cycle of seasons. Mothers counted breaths as their children slept. Time was not outside them, it was within. The paradox remains, is time something that exists independently of observers? Or is it woven from the very act of observation? If the universe could be stripped of all conscious beings, would time still pass? Or would the silent cosmos stand timeless, frozen until a mind arrived to divide one moment from another? The story of time may therefore be twofold. In the language of physics, it is entropy, expansion, the ticking of pulsars, the vibration of atoms. But in the language of human experience, it is memory, heartbeat, anticipation, and loss. Both are true. Both define reality. And so, the final truth may be that time before clocks has always flowed, not only in the stars and in the decay of matter, but in the fragile perception of living beings. The universe may keep its vast cycles and silent equations, but humans will always measure time in a glance, in a memory, in the fragile rhythm of their own breath. In the quiet darkness of the far future, there comes a question whispered across cosmology's vast halls of thought. Will time itself one day end? Physics describes the universe not only as a place of matter and energy, but as a flow defined by change. Entropy, the tendency for order to unravel into disorder, has long been the arrow of time's march. As stars burn out and galaxies drift farther apart, the cosmos loses the gradients that allow moments to be distinguished from one another. Heat death, the final, chilling prophecy, is the vision of a universe that has expended every drop of usable energy. No star will shine, no warmth will radiate, No difference will exist between one moment and the next. In such a horizon, clocks would still tick, but they would measure nothing, for nothing would happen. This scenario, rooted in the equations of thermodynamics, casts the ultimate stillness not as a dramatic collapse, but as a fading. The galaxies already tell this story in their slow retreat, redshifting into invisibility as the fabric of space expands faster than their light can reach. It is a future in which the rhythm of time itself dissolves into silence. The arrow breaks, the flow ceases, and time, as it has been known, may simply vanish, yet cosmology has never been satisfied with only one ending. The cyclic models propose another fate, that the universe, stretched to its limits, may fold back in upon itself, triggering a collapse, a big crunch. And in that collapse, perhaps, another beginning, another birth, another clock wound to tick again. In these visions, time is not a straight arrow but a wheel, endlessly turning each cosmos merely one bead on an infinite string. Some speculative cosmologies go further still. Loop quantum gravity suggests that at the smallest scales, space-time is not smooth, but woven from discrete quanta, like threads, in a tapestry. If true, then time may be able to reverse or bounce at those granular levels, preventing a final stillness. Instead, the universe could spring forth anew from the residue of its own collapse. Quantum cosmologists call this scenario a cosmic rebirth, a phoenix of time rising from the ashes of entropy. Then there are stranger visions still, those of eternal inflation. Here, the universe is not a single stage, but a vast foam of bubble universes, each with its own beginning, each with its own arrow of time. In such a multiverse, time never ends absolutely. It only dies locally, in each bubble, while countless others ignite elsewhere. In one, clocks may stop forever. In another, they may never have begun. The deeper physics moves into quantum gravity, the more uncertain time's future becomes. Some theories suggest that time is not fundamental at all, but emergent, an illusion born of entanglement, the relationships between particles. If so, then when the universe's structure evaporates into disorder, not only clocks, but time itself, may lose its meaning. Existence would remain, but without sequence, without rhythm, without the distinction between before and after a timeless sea, eternal yet unmoving. The human mind struggles to imagine such a condition, for perception is shaped by rhythm, the rise and fall of breath, the beat of the heart, the arc of the day. The end of time is not just the end of events, but the end of perception itself. It is a stillness so profound that even silence cannot describe it. Yet some scientists have dared to suggest that time may stretch endlessly forward, never ceasing, only thinning into a desert. In this scenario, even at maximum entropy, quantum fluctuations may still flicker in the void. Particles may emerge from nothing, momentarily rewriting the stillness with sparks of unpredictability. If true, then time may continue, but stripped of story, reduced to randomness without meaning. Still, another haunting possibility emerges from relativity itself. Einstein's equations allow for solutions in which time loops upon itself, closed time-like curves, paths through space-time that reconnect with their own origins. In such a universe, the future is not the end, but the return. Events endlessly revisited, like shadows cast on a turning wheel. Time, in this picture, is not a river, but a labyrinth, where endings and beginnings are indistinguishable. Each hypothesis, whether of death or rebirth, of collapse or cycle, reminds science of its own limits. Time has always been measured within the cosmos, never outside it. And if time is a feature of the universe, then it is impossible to know what, if anything, lies beyond its dissolution. The irony is sharp. The closer humanity comes to measuring time with impossible precision, the less certain it becomes that time itself is real. Atomic clocks divide seconds into billionths. Gravitational waves reveal tremors in space-time smaller than the nucleus of an atom. And yet, at the farthest edge, physics whispers that all these measurements may be tracing a ghost. That time is not a foundation, but a fleeting mirage. The future of time may not belong to stars or galaxies, but to questions themselves. For even if clocks stop, the mystery remains. Does existence require time, or does time require existence? Is the universe the stage upon which time performs, or is time the stage upon which the universe unfolds? If entropy ends the arrow, then perhaps existence will drift into eternal dusk. If cycles reign, then perhaps the arrow bends back upon itself, forever returning. If quantum rebirth is true, then perhaps the collapse is only the first note of another song. And if the timeless hypothesis holds, then time was never truly real to begin with. In every ending imagined, the paradox persists. Time may stop, clocks may break, yet existence, in its mute persistence, remains the greatest clock of all. And so the chapter closes not with certainty, but with awe. The future of time is not a horizon that can be seen, but a mystery that defines the horizon itself. Whether in stillness or in endless renewal, the cosmos continues to hold its secret close, and humanity, bound to its own brief heartbeat, continues to listen. Long before the first shadow was etched upon stone by the rising sun, before the first sundial cast its silent hand across the earth, there was already a rhythm flowing through the cosmos, the slow grinding of continents across molten plates, the patient sculpting of mountains lifted and worn down the silent drift of galaxies, as though carried on a current unseen. Time was not yet measured, and yet it was felt in the crumbling of cliffs, in the spirals of seashells, in the aging of stars whose hearts burned silently toward collapse. The universe did not wait for clocks to begin its journey. It unfolded in quiet persistence, an endless unfolding without witness or calendar. Then humanity appeared, a species restless in the face of mystery. With firelight they counted nights. With rivers they counted seasons. With stones they counted the years of their own passing. In each measure was the hope to anchor themselves against the vast indifference of eternity. From sundials to sandglasses, from pendulums to atomic pulses, the effort continued as though to tame infinity itself with the tick of gears. Yet the deeper science looked, the more elusive time became. Relativity revealed that no single clock governs all that time runs faster in the mountains than in the valleys, that astronauts circling Earth return younger than those who remain below. Each discovery pulled the fabric of certainty further apart, revealing that the thing most trusted, the passage of time, might be only a shadow cast by deeper laws. In quantum theory, the mystery deepens further. At the smallest scales, equations can be written without time at all. Particles do not march in sequence, but exist in superpositions entangled in relationships that care little for minutes or hours. Some physicists suggest that time itself is emergent, that it arises from entanglement patterns, from correlations written into the quantum state of the universe. If so, then time is not a stage, but a story, a narrative, created by memory and change. Julian Barber once described reality not as a river, but as a collection of nows, each one timeless and complete, each one existing like a page in a book that does not need to be read in order. The flow we feel, the arrow we cling to, may be nothing more than the mind stitching fragments together. We are the storytellers of existence, and the story we tell ourselves is called time. And yet the story has weight. It carries galaxies into collision. It erodes worlds into dust. It gives rhythm to a human life, a childhood that slips too quickly, a final breath that always arrives too soon. Even if the universe has no clocks, the heartbeat within the chest is enough to create the illusion of one for creatures, of memory time cannot be escaped. Now science peers further forward toward the long future when stars fade and galaxies grow dark. Entropy, the great law of disorder, ensures that one day all gradients will vanish. No more heat, no more energy to flow, no more arrow to follow. In that ultimate silence, time itself may dissolve, not with a bang, but with stillness, a universe without change, a cosmos without clocks. And yet perhaps endings are only beginnings veiled. Some speculate that time may loop, that the universe may cycle endlessly, expanding and contracting in breaths longer than eternity. Others imagine new universes budding from the decay of the old, reborn through quantum tunneling, reborn through possibilities still beyond our reach. In these visions, time does not end, but renews like seasons written across a canvas, far larger than the human mind can hold. What then of humanity, a fragile species of dust and thought that built, watches not to measure the stars, but to measure their own days? Clocks became more than instruments. They became symbols of mortality, tokens of the fact that life is lived within limits. By building them, humans sought to grasp eternity, but instead, they uncovered a deeper paradox, that the universe itself may never have needed them at all. Perhaps time is only the shadow cast when consciousness moves against the infinite. Perhaps existence is simply change, memory layered upon memory, order, giving way to disorder, and in the spaces between the mind creates the illusion of flow. The question lingers, does time exist? Or is it only the story matter tells itself as it dances through the void? No clock can answer. No equation can settle it fully. It remains the most intimate of mysteries, for in every tick of a second hand, in every swing of a pendulum, human beings hear not the beat of the universe, but the echo of their own heartbeat, the sound of existence trying to measure itself. The camera drifts outward from a clock on a table, to a city of lights, to a planet spinning slowly in the black, to galaxies wheeling soundlessly in the deep. And in that silence, it becomes clear. The universe is vast enough to exist without time, but humanity is small enough to need it. And so, the final paradox endures a cosmos that may be timeless, and a species that cannot live without the illusion of ours, a universe without a watchmaker and a people who will never stop building clocks.